Another type of equation you can have is something called an absolute value equation. So an absolute value of equation is a little different than a regular equation because it contains an absolute value, right? Duh, obviously. You can solve these types of equations by solving two related linear equations. So you have to solve two different equations. The equations that you're going to solve, right, to solve ax plus b, right, an absolute value of ax plus b equals c. So this is just like the general formula when c is greater than 0, because we know that absolute values are always positive because they just represent distance. Remember, absolute value just stands for the distance a number is from 0. So distance we always consider positive. So one equation that you're going to solve is ax plus b equals c. So that's just pretty simple. You just take the lines away and you make the equation. But remember, things like -5 have the same absolute value as +5, right? Because they're both 5 units away from 0. So we also have to solve its partner equation, which is ax plus b equals -c, right? Because just like my example, 5 and -5 have the same final absolute value. So you don't really know which way you're going. So you have to solve two equations. Here we've got a little fun fact. When the c value is negative, you can't have a solution, right? We say that you have no solution, which is something we looked at earlier in this chapter, because absolute value always represents non-negative values because it represents distance, and distance is always positive. So here we go, example 1. We're going to solve each equation, and then we're going to graph it if possible. So I'll show you how we do that. But in order to do this, we need to solve two different equations, right? One equation is going to say x minus 4 equals 6. The other equation is going to say x minus 4 equals -6 because they both have the same absolute value. So this equation, pretty simple, right? You add 4 to both sides, you get x equals 10. And then the other one, you do the same thing, you add 4, but this time you get -2. So these are my two answers to the equation, x equals 10, or x could be -2 because you don't really know which value of x it is. And then we just make a quick little number line. I'll put -2 as my lowest, then I'll go 0, 2, 4, 6, 8, 10, okay? Now I have a dot here at 10 and a dot here at -2. And what you should notice is that 4 is right in the middle because this one is 6 to the left and this one is 6 to the right. And 4 was right up here in the equation. So, interesting. So now we look at example B. And before you do anything, you have to pause and look at the equation. Don't just be like some robot that's calculating equations without really looking at them. If you look at this, it just says an absolute value is equal to -5. Now, I told you like 2 minutes ago that absolute values are always positive because they represent distance, and distance is always positive. So, since this says the absolute value of a number is -5, obviously there is no answer because you can't have a negative absolute value. So we don't need to even do anything. We just write no solution. So there is no number that's going to make this equation true. All right, let's look at one that's a little more complex, multi-step equation. So you follow the same things. You do GEMDAS. Okay, remember GEMDAS is grouping symbols, exponents, multiplication, division, addition, subtraction. And when we're solving, we go backwards. If we're just regular calculating, we go forwards. So the first thing I'm going to look for in my multi-step equation is subtraction or addition. So I have subtraction, so I'm going to inverse it by using addition. So I'm going to add 10 to both sides. And when you bring it down, you have to bring down the absolute value because you haven't done anything to that yet. And so it equals 6. Now, these absolute value symbols represent grouping symbols, right? Remember, it's more than just parentheses. So I can't just subtract 9 because it's being blocked by these grouping symbols, and that's why we have this other technique where you break it up into two equations. So I have 3x plus 9 equals 6, and then the other equation is 3x plus 9 equals negative 6, because the absolute value of 6 and the absolute value of negative 6 have the same distance from 0. So this equation, you can kind of do all the steps, blah, blah, blah. 3x is going to be equal to negative 3, and so then we get x is negative 1. For this one, we get 3x equals negative 15, and so x is equal to negative 5. So those are my two values of x. And let's move on to the next question. A little more complicated, but now we're going to look at equations where we have an absolute value on both sides. But the technique is still the same. They either equal each other or they equal their opposites of each other. So this is pretty much the same as what we did on the other thing. You take ax plus b and it equals the positive version, or ax plus b equals the negative version. The only trick, though, is if you have a multi-step inequality or a multi-step absolute value, you're going to have to distribute that negative sign when you look over here. And we'll see that in example B. But let's just look at example A first, a little simpler. So I have two absolute values equal to each other. So one option is that 3x minus 4 equals x. The other option is that 3x minus 4 equals negative x. So that's not like so different than what we just did, only it's a variable. So I have to move variables to one side, numbers to the other. So I'll move the x over. So actually that's wrong. I should move the 3x over, because the right side only has variables. So I'm going to subtract 3x. So I get negative 4 equals negative 2x, and divide by negative 2. So x is equal to 2. For this one, if I subtract 3x, I get negative 4 is equal to negative 4x. So x is equal to 1. So those are my two possible values for x in letter A. So very similar to what we did in the other question. A little more complicated when we get to letter B, but it's the same technique. Either it equals the positive version or it equals the negative version of the absolute value. So one possibility is that 4x minus 10 is equal to 2 times 3x plus 1. We're going to hold off on that other equation for a moment because it gets a little trickier. So let's just solve this one and get our answer for x first. So I get 4x minus 10 equals 6x plus 2. So then I move things around. I'm just going to kind of move them in my head. I'll get 2x on the right. When I subtract 4x, I will get negative 12 on the left when I subtract 2. So I get x equals negative 6. I did a couple of steps in my head. Hope that's okay with you. If you want me to show the steps in class, I certainly can. So that's one value of x. All right. Another equation that you could write, right? So this is if I just keep it and I say the absolute value equals the positive. Another equation that I could do is 4x minus 10 equals 2 times negative 3x minus 1. And where I got that was I did negative 1 times 3x plus 1 because I took this absolute value and I did the negative version of it. So now you just solve that equation and you get 4x minus 10 equals negative 6x minus 2. Move things around. I'll move variables to the left. I'll get 10x minus 10 equals negative 2. Then I'll move the 10. 10x equals 8. Ugh. So that's 0.8. Alright, you get a decimal. Don't freak out. It's not really super friendly, but that's what we got. This example is much more complicated. A lot of them are not as complicated as this. They usually just have one absolute value in them, but this is what it would look like with 2. Not only do equations potentially have one solution or two solutions, right? In an earlier lesson, we talked about how some equations have no solution and other equations have an infinite amount of solutions. But sometimes when an equation looks like it has multiple solutions, it actually might have something called an extraneous solution. And it has the root word extra in it, which means it's an extra solution. An extraneous solution is a solution that looks like it should be true, but if you actually go and check it, it gets rejected. So that's another reason why it's important to check. So you won't necessarily see extraneous solutions, so you have to go through all the work and then check it afterwards. So in example 5, one equation would be 2x plus 12 equals 4x. And then the other equation is going to be 2x plus 12 equals negative 4x. So we just kind of do our work and see what we get. So I'm going to move variables to the right, so I'll get 12 equals 2x. So then x is 6. I did all those steps in my head. But I showed my work. And then for this other one, I'll move the 2x over, and I got 12 equals negative 6x. So x is negative 2. And then you circle them and write like you assume that you can just move on. X is 6 and x is negative 2. But look what happens when you go to plug them in. So when I check 6, I get absolute value of 2 times 6 plus 12 equals 4 times 6. And so I get absolute value of 12 plus 12 equals 24. And that's true, right? The absolute value of 24 is equal to 24, right? That works. Okay. But when you plug in negative 2, it doesn't work. Watch this. 2 times negative 2 plus 12 equals 4 times negative 2. So the absolute value of negative 4 plus 12 is equal to negative 8. And you probably can maybe see where this is going because I told you absolute values can't be negative. You get the absolute value of 8 equals negative 8. And obviously that is not true. So negative 2 gets rejected and the only answer is x equals 6. Okay, I would like you to try example 6 on your own. Remember, you have to set up 2 different equations, and I also want you to check for extraneous solutions. So pause the video, try it on your own, and when you're ready, click play, and you'll get to see my work. Alright, so there's my work. First thing I did was I made my 2 equations. And when I did the second equation, I did the negative of the absolute value, which was negative x minus 11. So I distributed the negative sign to everything. Then I solved. This one didn't give me a solution because I had 5 equals 11, which obviously is not correct. And then this one gave me a solution, but I had to check to make sure it was or was not extraneous. When I plugged it in, it worked. So the only solution that works is x equals negative 8. If you have any questions, write them down and ask me when you come to class.